Hello everyone, and welcome to my talk about Renku. My name is Sandra Savchenko-de Jong, and I'm with the Swiss Data Science Center. So first, I want to talk a little bit about issues that many of you may have seen working in data science. For example, you have a very beautiful plot, but you don't actually know how it was created, where the data came from, or you or your colleagues have written a paper in Nature, and there's some new data available. And now, I'm a little bit from my apropos here. Okay, so for example, you or your colleagues have written a paper in Nature, and you suddenly come upon some new data, and you wonder, I wonder what that means for my last year's results. And what happens to us, especially if we work in companies, is that the person before us had created some great models, some great results, and you actually, you're not entirely sure how they did it, so you kind of have to reverse engineer this information. And if you work, for example, with confidential data, what might happen is that you want to run an algorithm on someone else's data, and how can you do that in a safe way? Or completely different problem, you have a data set and you want to train a model on it, which might be a bit compute intensive, and you wonder, well, I'm probably not the first person to think of this. I wonder if someone else had already done it. And lastly, especially for scientists, this is a problem. You create a beautiful algorithm, you have a really nice data set that you have put all your time into to make nicely available, and then people are probably using it, but you don't really know it, and first of all, they're not citing you. Obviously, I'm not the first person to address these issues. There are many solutions nowadays which exist to solve at least part of these questions. People nowadays use Git often for version control and collaboration. To collaborate on papers, you can use Overleaf, Google Drive, Evernote, and to have this reusable environment, people use Docker containers. Even completely rerunnable pipelines exist using, for example, Luigi CWL, and there's also many other things which I learned about in this conference, which I didn't put on my slides, like Binder, like Binder, and but we heard this morning about Pangeo. So what Renku does is it combines existing technologies, such as some of the ones that I've listed here, and new technologies to provide a one-stop shop for the complete data science process. So as I said, I'm from the Swiss Data Science Center. I guess most of you are not from Switzerland, so you might not have heard about us. So I will first talk a little bit about what the Swiss Data Science Center is. After that, I will talk to you about the platform itself. And sorry, it's a bit difficult to be talking in the microphone and also looking on my slides. And after that, well, we'll just conclude the whole talk. So the Swiss Data Science Center is a national project in Switzerland. It's a collaboration between the two biggest technical universities in Switzerland, the EPFL in Lausanne, and some of you might know that because that's where Scala was developed, and ETH in Zurich. So SDSC is like a startup within the university, so we are government employees, but we're not a lab in the sense that we do not have PhD students. And we are also not driven by profit. So we have the idea is that we can sustain ourselves, so to say, but right now we're working from some government grants. The SDSC started in 2017. I myself have been part of it for about 1 year now. And currently there are 25 people working there. We have several software engineers, we have data scientists, and there are some people that are doing other stuff like management and administration. So the mission of SDSC is basically to promote open data science, and especially in Switzerland, data science started to come up, but it's not really very well adopted everywhere. And part of our mission is to help with this adoption. And we do that by being involved in projects, both from the ETH domain in academic projects and in industrial projects, and that is also beyond Switzerland. And the second part of that is that we are developing the platform Renku. And that is what my talk is about. And SDSC kind of places itself in the middle. So on the one hand, you have the basic research in data science. So that's really development of code, of machine learning techniques, of work on data privacy and security. And on the other hand, you have the domain expertise. So people in companies, they might have very extensive knowledge of the manufacturing process. And people that work in environmental sciences, they know exactly how the processes work in their domain. And then in between that, there is the applied research, so the application of these machine learning techniques, of these statistical methods on this domain science. And that is where SDSC places itself. So we are trying to interface between. And as I said, our mission is really to help with the adoption of data science and machine learning techniques in the academic community and the industrial sector. So we do, so the academic community, what we do is that we have a call for projects occasionally, and then a lab can apply to work with us, because we really want to have a collaboration. We don't just want to send a data scientist out for 3 months, solve the problem, and that's that. We really want to have a sort of sustained collaboration. So let's talk about Renku. It's probably what you're here for. First, I will talk to you a bit about how we envision Renku, because it is a platform in progress. It's a platform in development. It's not completely done yet, I'll be honest. And I will talk a little bit about the technical details. And because I'm not brave enough to do a demo, I will show you how you can interact with the platform. I'm not going to do the demo. And then I will tell you what's the next pieces which will be coming. So Renku is actually not a Swiss word, surprise. It's a Japanese word, and it is a form of poetry. So what happens if, in this idea of collaborative poetry, is that each poet writes a stanza, or a coup in this case, and which are all combined together to create a beautiful poem. And that's kind of how we see data science, is this really collaborative effort to create a beautiful result, basically. So these are the five main pillars, so to say, of the Renku platform. So first off is that we want to create the means to make data science reproducible. And I think that is something that we have heard of in several talks already, the fact that this is something that is often still missing in many data science projects. And what is also important is that we will be able to share and reuse results, code, algorithms for later use in different projects, or for maybe rerunning your analysis. And we really want to create an environment which is where it's easy to collaborate with others, and then not just people of your own group, of your own discipline, but really have this multidisciplinary environment. We want people to be able to search for data, to search for methods as well. And lastly, we are working on having a federated environment. So that means that there is several institutions which each have their own version of Renku, and they will have the freedom to say, for example, I don't want to have my complete compute available for everyone, or I don't want my data to be available for everyone. They can still have control. And for many universities, this is important, but also, for example, for hospitals, because they don't want to have everything freely available, thank God. So this is done basically by capturing the lineage. And with the lineage, I mean how a result was achieved. So the lineage of a data set is how it was produced. And by capturing this, by the moment that someone starts to use Renku, we keep track of how they achieve their results. We record this and then exploit this later. This is how we want to enable all these features that I just had shown you. Especially in science nowadays, there is a lot of data available, and this data is often not easy to combine with each other. I mean, even in the same field, in astrophysics, there will be, for example, the talk that was given yesterday, they were talking a little bit about this multi-messenger approach to events, for example, and what happens is that you have data which is in different forms. The FAIR principles were developed about 4 years ago with the idea of how can we describe data in such a way that you can easily reuse them, find them, access them, and combine them with each other. So FAIR stands for findable, accessible, interoperable, and reusable. And, well, I mean, it kind of speaks for itself. And the data which is stored in Renku will be able to, well, they will apply, how do you say that? They will be, sorry, I'm blanking out. We enable the FAIR principles, basically, because the data which is saved in Renku, everything is tracked, everything has been labeled with the proper metadata. We actually provide APIs for easy access of the data and of the code, and the data is in a standard form, so it's easily to be read both by machines and by people. And because we have this lineage, it's also possible for the data to be very easily reused. Renku does much more than that, but it also complies to the FAIR principles. So let's say you are a data scientist and you get to work, right? So you start with the raw data. You will often have to do some pre-processing for this, and this will give you some process data. And to get your result, you might need some other data. All this is recorded in a knowledge graph. And a knowledge graph is basically the database where everything is stored what happened in Renku. So that's the data, that's the metadata, that's the code. Everything is stored in a knowledge graph. And because we record these steps, they can be reused and be repeated. We have a built-in version control. We use Git for this. We'll talk about that later a bit more. And we also enable the people that use Renku to very easily access the lineage so that you can visually see where your data comes from. And because we store questions can be asked later. Because we store the metadata and the algorithms, afterwards it's also possible to search for them. So you can search not just for the data, for example, I want to know if someone used a Titanic data, like to talk about a very favorite data set, but we also want to enable people to search for algorithms, patterns within relationships. So for example, did someone use this data set for this purpose? This kind of stuff which would be very useful to have access to. And as I said, so we have the little, from the beginning, you have your data set, you analyzed it, and then you see, for example, you search around and you think, oh, you know what? I wonder how this would interact with this other data set which I found. And it's very easy then to combine these things together, but still preserve the lineage, so you still know where it came from. And that is really how we see the data science process working. So this is the big theory around it. Now, I want to talk a bit about the system aspect, so how we have built the platform. And we use the modular architecture, so we want the components to be reused, and we also wanted to be able for people to extend and build their own modules on the platform. Everything is open source, of course, and we use a lot of proven standards and technologies, for example, Jupyter. Right now we have the platform is written in JavaScript for the front end, Scala and Python, but we are basically language agnostic. For us, it's more like if someone wants to develop a piece of a module for our platform, you can do that in Go if you want. It's just that right now we chose these languages because that's the ones that we were most comfortable with. So as I said, we use a lot of technologies that already existed, such as GitLab, Jupyter. Actually, Jupyter, we are now switching to Jupyter Lab, but just didn't update the slide yet. We also use Jupyter Hub. We do our deployments with Kubernetes and Helm. And we use the CWL, the Common Workflow Language, to track the pipeline. So this is a really high-level overview of the architecture. We have the user-facing parts, which is the web UI and the CLI, the command line interface. And that is something that I will demonstrate a little bit later. These both talk to a gateway or a proxy, because that's the way we can very easily enforce authentication and authorization. There's much more backend services than this. These are just the ones that I thought were most interesting to show. We have a notebook service. We have Jupyter Hub, as I said. And we have the KG, which is the knowledge graph. So that's where everything is stored. So the gateway, the Keycloak, GitLab, everything produces events. And these events are then piped to the knowledge graph. And so, for example, if someone adds data with the metadata, this information is sent through the events queue and is recorded. And afterwards, other services can then query again the knowledge graph to say, for example, do I have this data? And the way we build the knowledge graph is that it's very easy to query in a very fast way. The graph itself is immutable, so once it's there, it's there. And it contains both information on the data and the metadata, and also the other services can query it for whatever reason that they want. So now we go to the kind of interactive part. So as I said, there's two ways to interact with the platform. You can either use the web-based front-end, the UI, and the CLI. Well, let's start with the UI because it makes for better images. And I do think that is the thing that people will mostly use, because this is the online component where people can really share and collaborate. The CLI is something that's on your own machine, so that is not a part where you would easily, you can easily do with someone else unless they're physically next to you. And we have Jupyter integrated in like almost every part of the UI because we want people to be able to use their notebooks at any moment, basically. So. Okay, so let's start. You have logged into Renku. You do have to log in. And you want to create a new project. It's very simple. You can go to your list of projects, and then you see all the projects which are publicly available for you. Right now, we support just the GitLab public-private projects, but we do want to have more, how would you say that? Delicate way of dealing with this later, but for now we just have your project is either public or private. That's it. So I see a list of projects that my colleagues made. There's also one of myself. And you can make a new project very easily. You give it a title and a description. This is also just how you make it in GitLab. And then you set the visibility either to public or private. And then you have a new project. And as you can see, your project standard comes with some initial files. So these are the Git files and the metadata files. There is also a Docker file and a requirements file. And these two files are used to make a custom notebook image. And that is the little block you can see there, because the moment you create your project, a notebook's image is being built for you. So that takes a little bit of time. But then you have your very own custom notebook image. So let's say you have done already some work, so you have some files. So you can see we divide the files which are there in data, in notebooks, and in workflows. So for my notebooks, I have some notebooks here. And I'm sure that this is something other people may or may not have had as well. But when the time before Jupyter Lab, so what would happen sometimes is that you have, you make like 10 notebooks, and you're not very smart like me, so you just give them very not so great names, and then you have to open all your notebooks to find out what was the one you were searching for. So what we build in is that if you look in your notebooks folder, you just have a very quick preview of your actual notebook. So you can't just be like, I think I called this start analysis 1 to 5, or was it start analysis 1 to 6? I can just quickly compare, and then if you have at least the thought to write the first cell properly, then you know exactly which notebook you want to use. And then you can launch the notebook from there, and then you can use it. So let's say you did some analysis in your notebook, and you are like, you're done for the day. You're like, okay, time to go home. What you do is that, because we use the GitLab as a backend, you can commit and push your changes after saving your notebook. Then you go back to the Renku UI, and you see this sign which says, do you want to create a change? So right now, we only support one branching, basically. I mean, GitLab, of course, support many branches, but for now, we just have this idea of you have one branch, and every change you make gets pushed to this master branch. And as many of you know, it's a good practice to make sure that people don't push directly to the master branch, but they make a merge request. And that is basically what happens here. So when you commit your code, it's put on a separate branch. And then this prompts you to say, like, you want to make a change. Yeah, we do. Here you can see a preview, and you can see the diff, so the differences between the notebooks, and it's a very visual overview. Well, in this case, I was very lucky because I don't have merge conflicts, so I can merge it directly. That's very useful. What happens if you do have merge conflicts right now? We still need you to go to GitLab to solve your merge conflicts. But in this case, it was okay, so you can just merge, and everything's okay. As I said before, so the idea of the collaborative poem is that you use coups to create your stanzas, and we have these also in our project, in Renku. The coup is like an extension of a GitLab issue, so it's more than just something you would use to say, hey, I found a bug, don't do that. Here, for example, one of my projects, I have a list of coups, and they're like from me and another colleague that I badgered into making a coup on my project for the purpose of this presentation. And you can ask questions and you can reply. And what you can also do is that you can open and refer to notebooks from a coup itself. So for example, I have a question and I can directly copy paste my notebook in there and then launch it from there as well. As I mentioned before, we also have a small notebook service, and this links Jupyter Hub with GitLab. And what happens is that every time you push to your project, an image is being made from the Docker file and the requirements file of the project. So every time you update it, you have a new image, and you can directly launch a Jupyter server based on your project and your commit hash. And you can basically retrieve the state of your project at any moment. So you can just go back like 3 days and be like, okay, at this point it still worked. I launch it from there, and then I can hopefully see the differences, and then very easily, okay, oh yeah, oh, I forgot that import. Yeah, that's probably the problem why. Now, the CLI, so that's the offline component, it actually also works online. But this has the benefit that it can be run without the full platform. So this is something you can install on your laptop because it's on the PyPy registry. And the CLI has had a slightly different evolution than the UI. So this is, for now, you can only run the reproducible workflows on the CLI, but they work together. So you have a project in your CLI, you can also push it to the UI. Okay, the CLI has a very straightforward, how do you say that, syntax. There's much more to the CLI than just this, because I mean I couldn't like write everything off it. But so assuming you want to have a project, you can very easily create a data set, and you call it my data because you're not very original. You add a file to it. And you can run an analysis on this. It's Renku run analysis on your data set, and then you pipe that to an output. And what you can do then is view the lineage of your output, so you can see where it came from. Some other features which I didn't show here is that you can, the moment you actually change your data set, it automatically reruns your analysis, creating a new output. But here I just want to show like the very kind of basic steps. So for example, I have a data set, which is the Fermi 3 lag, and I do an analysis, which is I do a grep command. It's very basic. I grep for a word which I think is going to be in there, and that's FSRQ, and I pipe that to an output, and I do the same thing for another word that I think that's probably in there. And then afterwards, I check for both of these the lineage. So in this case, it's very simple. It's the word. There's this workflow, which is automatically created and stored in this .renku/workflow folder. It has a very long hash, and then it's called grep because I did a grep command, and it's a CWL file. So this is this common workflow language, and then it shows that it came from this Fermi 3 lag. Now what you can do is use these outputs as input for a new pipeline. So I now run an analysis which is called, which is basically a word count on both of the files that I made, and I pipe that to a new file. And now you can see a bit better this idea of the lineage. So on top there is the word count file. This is the new result, the workflow which created that, and on 2 times the workflows which created the intermediate files going all the way back to the beginning. This is not like super clear, but what you can do is then push your project to the UI, and then you get this much more clearer overview. It's inverted, by the way. So now we start on the top with the data set. You have the 2 workflows creating the intermediate files. There's a workflow which combines them, and then you get this output. I mean, obviously, if you have a lot of analysis, this is going to become much larger than that, but for the purposes of demonstrating it, I used kind of a much more quicker, easier analysis. So that was already kind of what we want, what we have. So there's still some diff in between. So what's the next step for the SDSC? As I mentioned, we now use the GitLab public-private project for our security. What we want to do is to create a bit more of a fine-maced way of securing projects using attribute-based access control. And this is something that would allow for much more control for users so that they can say, I want to have this part of my data which can be exposed and this part not, for example. We are working on the federated mode. This is something that we don't have yet, but there's a demand for it because we work with several institutions which would need this. As I mentioned, the workflow execution right now we only have in the offline analysis. This is going to be in the cloud, and that's something that should be done pretty soon. For the lineage, we want to create a better ontology and metadata standards, because right now we used our own, but we want to see if we can standardize this. And the graph search functionality is not exposed. It has been implemented, but it's not exposed right now. With some of our academic partners, we are working on some plugins, one of them being for recommender systems. So what happens if I have a data set and I wonder what other people did with it, and we work on data and code discovery as well. And there are several other plugins that we are working on, and we hope other people will also contribute to. So yeah, these issues from the beginning, in its complete form, Renku should be able to basically resolve most of them, because, well, you definitely know where the data for where your plot came from, because it is all trapped in the lineage. You can rerun your analysis with the new data. And the reproducibility also allows you to see how someone else created the same results. I mean, this is all assuming that they were smart enough to use Renku, right? I mean, if they didn't, then you still don't know anything. With the federated mode, when we have implemented that, you should be able to have data in one place, code in another place, and combine them. When the search function enabled, you can search for relations like, did someone ever train this model on this data, or did this person use that data set? And lastly, because of the lineage, you should also be able to see from the data that you created, from the code that you created, who has been using that. So if you want to know more, we have read the docs. You can look upon our code and judge us if you feel so inclined. You can also not judge us. The data science CH is our official page. We talk a little bit about the platform in a more fluent way, probably. And we have first steps. If you are wanting to use Renku, and you can, because we have a Renku lab live, you can go there, make an account, and you can start trying out Renku. It is still, we're still actively developing it, so there might be points where things might not work, but we were hoping that people can try it, and maybe they can, make an issue on our Git and say like, hey, I tried this and it broke completely, send help. And we are we hope that people want to use our platform and enjoy it. Thank you. Well, I still think I have some time for questions. Please.
The question about storing a graph and the process graph, are you using any kind of graph database or graph data structure?
Yeah, we have based our knowledge graph on Janus graph, and you can query it using Tinkerbell. So we use an existing technology for that, Janus graph.
When you commit your notebooks, every time you run it, the notebooks change. How do you deal with that? Even if you don't make any changes, just by running it.
Yeah. So right now we ask people to kindly clear their outputs before committing it, because else you will definitely run into a merge conflict. Yeah. Because the moment that you run it, if you run it twice, one cell, then you all had these different things in front. Yeah, right now we just ask people to just clear all the outputs before committing it. I'm not sure if there are really ways to properly address that, but that is definitely something we want to take into account. Yes.
To answer, maybe you can configure Jupyter with save books,
yeah,
and you can decide that anything you want can happen before you save.
Okay, save books.
Yeah.
Okay.
There is pre-save before it even touches the disk, and then you can have a post-save processing.
Okay. Oh, thank you.
One more question. In the beginning, you mentioned how you have that figure in a Nature paper.
Yeah.
How would that now relate to Renku? Can I use Renku to publish my next Nature paper and have it reproduced?
Oh, it would be a great honor. Well, we want to work towards that. Right now, so the idea what we have is that if you have a data set and a workflow producing a result, when you substitute your data set for another data set, you can rerun the exact same workflow and get a new result. We don't have automatic publishing yet, but we do want to be able to help people with creating papers in Jupyter notebooks, for example. Thank you. Yeah?
So you've shown that in the command line interface, you're tracking commands and produced output files, and that goes into your dependency graph, your Lineage. Does something equivalent take place when you operate with a notebook? And is this on a per cell basis or per notebook?
That's a good question. Yeah, so the thing is that I would say that the notebook itself is then the analysis. So it would be input, notebook, output. And because that is something we had in an earlier version, but we actually changed a lot of stuff between versions. So in the earlier version, you had an input data set and your notebook would generate output. So I think that is how that would work.
So running the notebook is then like entering one command.
Yes, exactly. Yeah, because also, we now, what I showed was still with the Jupyter notebooks, but we actually moved to Jupyter Lab. So I think that might also have some implications. But I told my colleagues, I'm going to give a presentation. Don't change anything. Now we just have Jupyter Lab. I mean, it's intercommunications because we're in two different cities. Yeah.
For the lineage tracking, it's very interesting. Is it only going to track the command and the parameters are passed by command? Can I track environment variables that command invoked in, or maybe some version of the binary that ran?
No, everything's tracked because but not so that would be then in the metadata probably. But I mean, obviously, what I show here is like this. It's this high level overview, and also what do you want to expose to people using it. But yeah, we track everything, all the versions. I'm not sure if we will be able to expose everything. Yeah.
So in your architecture slide, you had the backend database. Do you have any kind of data management software on top of that? The storage service?
Yeah, the storage service is something that a colleague of mine has written, and we do have different backends that people can use. Like for right now, we mostly use GitLab, but we also allow people to use, for example, Azure for their storage. But we have kind of based it around the idea of the Git LFS.
And I guess that to preserve the computational environment, you ask people to provide the requirements file or some kind of, and then this creates a container.
Yeah, well, you get the requirements file for free when you start. It's
yes,
just,
and I guess I can modify it.
Yeah, you can do that.
And what's the plan to preserve this so I could keep this in a repository?
Well, this is just part of the things that are committed to Git. So the moment you change it, then it's just a file change.
And so here's the tricky question. If I then want to go back to a container from some years ago, like apply this data to a native figure from 5 years ago, would you then try to rebuild the local container at the time? Or how do we
You want to have your new data with your old Docker file.
Correct. And I wonder, if you just store the Docker file, that may require to run Docker build.
Yeah.
And I'm a little bit concerned about Ubuntu not offering the right files at that stage to run get update, which may be a standard thing.
Well, we preserve the images, but I don't know for how long.
But that would be a solution, preserve the images.
Yes. Yeah, I mean the Docker file, of course, it's stored in Git, but you know, Git also can store the notebook images, which is what we do because that's how we do this thing with the notebook server, that you can get your project back at any status because the Docker files and images are all stored in GitLab as well. But if you would have your Docker file and you want to use different data, I'm sure that there is a way to do that. It's not really a use case that we really considered yet.
You're not that old.
I'm older than 5, huh? But but thanks. It's something that we should keep into account. Okay, well, thank you so much, and yeah, I hope that you would that you want to give a look, give a try to our platform.